Okay, so today we have another past year problem from the 2023 June examination for Math130, and it says use implicit differentiation to evaluate dy dx at the coordinates x, y, 0, 0, given the equation, and then we have this equation. So firstly, I'm going to take the derivative of both sides, so we're going to say d dx of y times e to the sine x, and that's going to be equal to d dx of x cos y. Okay, so notice that we have a product rule on the left and right hand side. So let's start with the left hand side. I'm going to leave the first function exactly how it is, and I'm going to derive the second function. Okay, so multiplied by, so the derivative of e to the sine x is e to the sine x, and then multiplied by the derivative of the exponent. So the derivative of sine x is just cos x. So we have a product rule, so I'm going to add. We left the first function alone, so I'm going to derive the first function. So the derivative of dy dx, or the derivative of y, excuse me, is dy dx. And then we can just leave the second function exactly how it is, so e to the sine x. Okay, that's going to be equal to, so now we're moving on to the right hand side. I'm going to leave the first function how it is and take the derivative of cos y. Now before I take the derivative of cos y, the derivative of cos x is just minus sine x. But using the chain rule, we still have to derive the angle, and the derivative of x with respect to x is just 1. But we don't really write it because it's just going to be minus sine x. So keep that in mind. So taking the derivative of cos y, it's going to be multiplied by minus sine y. And then using the chain rule, if we derive the angle, it's going to be multiplied again by dy dx. Okay, so we have a product rule, so we're going to add. We can say, okay, derivative of x with respect to x is just 1, and then we can leave cos y. Okay, let me tidy this up a bit. So I'm going to say this is y cos x multiplied by e to the sine x. Then I'm going to put this derivative at the back, so I'm going to say e to the sine x dy dx. And then on the right hand side, this is going to be minus x sine y multiplied here dy dx, and then 1 times cos y is just going to be cos y. And I'm going to erase this part so don't get confused. Okay, so solving for dy dx, I'm going to get all the terms of dy dx to the left hand side. So this one's already on the left hand side, so I'm going to have to move this one. Actually, I'm going to put that in a different color. I'm going to move this one, and then I'm going to move this one to the right hand side because it doesn't have a dy dx. So doing that, we can have e to the sine x, which is this one, dy dx, and then moving that to the left hand side, it's going to become positive x sine y dy dx. Now moving this one to the right hand side, I'm going to put down my cos y first, and then that's going to become minus, so minus cos x multiplied by e to the sine x. Okay, so far so good. And now I'm going to factor out a dy dx from the left hand side. So dy dx, open brackets, that's going to be e sine x plus x sine y, and then this is going to stay the same, so cos y minus y cos x multiplied by e to the sine of x. Okay, so if we divide both sides by this term, we get dy dx is then equal to cos y minus y times cos x times e to the sine x, and that's going to be all over e to the sine x plus x into sine y. So this is my derivative of this equation, but they want the derivative of the equation at the coordinates x, y, 0, 0. So then we can say, okay, at x, y equals 0, 0, this is going to be cos 0 minus 0 into cos 0 into e to the sine of 0 all over e to the sine of 0 plus 0 into sine 0. Okay, so cos 0, let's think about this. So if we have our graph of cos x, we know that cos x goes 1, 0, negative 1, 0, and then back to 1. So cos of 0 is just going to be 1. So 1 minus, so we could evaluate all of this, but if we do evaluate this, it's just going to be multiplied by 0, which is just going to give me 0. Okay, now e to the sine of 0. Okay, let's think about sine of 0. So I'm going to erase this. Okay, so sine goes 0, 1, 0, negative 1, 0, and then back to 1, or however, carries on. So if we think about sine of 0, that's just going to be 0, so we're going to have e to the power 0 plus, again, we could work this out, I mean we have worked it out, but that's just going to be 0. Simplifying this, we have, this is just going to be 1 over anything to the power 0 is 1, so our final answer is just 1. So the value of the derivative of this function at the coordinates x, y, 0, 0 is just 1.